record. All right. So Algebra 1, adding and subtracting polynomials. Okay, polynomials. Let's find out just what in the heck are polynomials. Polynomials, they are monomials. Okay, we all know what those are. That was last chapter now. They're monomials or the sum of monomials. Okay? Technically speaking, it could be sum or difference of monomials. Subtractions are okay. Alright, because honestly you could just rewrite it as addition of a negative, so subtractions are good too. And each monomial we call a term of the polynomial. Alright, so monomials were like 2x squared. Alright, 3xy to the third, stuff like that. Individually based. Now, we're going to start adding and subtracting these guys together. Okay, now, there are two special polynomials you have to know. The first one is called a binomial, which is the sum of two monomials. 2x squared plus 7, down at the bottom right there. Okay, the second one is called a trinomial, the sum of three monomials. Okay, x cubed minus 10x plus 1. Shouldn't be hard. If anything, think of a bicycle and a tricycle. Bicycle has how many wheels?
Two.
Two. Binomial has how many terms?
Two.
Two. Tricycle has how many wheels?
Three.
The trinomial has how many terms?
Three.
See how easy it is? Okay, it's just like riding a bike. He made a funny. Oh.
LOL.
Oh, Mr. Mormon, he's a funny son gun. But as we move forward in this chapter, I'm going to say binomial and trinomial more often than I'm going to say any other word. Okay, the rest of this section. Okay, you have to understand what those two terms or what those two words mean. Okay, because I'm going to say, okay, you turn this trinomial into two binomials. You take the sum of the two trinomials. You FOIL the two binomials. You have to know what that stuff is. Otherwise, the rest goes poof. Okay? So, a polynomial, and a polynomial after that, okay, say you had four terms, right? Say it was like, then you get into the technical ones I don't need you to know. Okay? And we just generalize them by calling them polynomials, alrighty?
Oh, okay.
So a polynomial is like a general term. Okay, you could have like 8 terms in a polynomial. It's all stretched out. There probably is a fancy dancy word for it. I don't know what it is.
Octanomial.
Maybe, I don't know. Okay. There are fancy words for 4 and 5. They're not like penta and quad. Alright. So they get a little more technical and we don't talk about those till on number 2. Okay. But the ones you definitely need to know, binomial, trinomial. Okay, some other major players on the vocab side of things for this section. First one being degree. Okay, now a degree is the largest exponent. Okay, the largest exponent in a polynomial. Whatever the biggest exponent is, that's the degree. Okay, if you come in here when Algebra 2 kids are in here lately, you've probably heard me say that word before. Okay, degree and leading coefficient. That's what they're working on right now. Okay, standard form. This one's important. When the terms of a polynomial are in order from greatest to least degree, also known as greatest to least exponent. So they go down in order from exponents: 5 to 4 to 3 to 2 to 1 to none. Okay, that's all standard form is, with the coefficients that are attached to them going with them. Okay. Now, when you are written in standard form, if you go down in degrees, then the biggest exponent will be written first, logically. Yes?
Yes.
Okay. So whenever that biggest exponent is written first, also known as the degree, the coefficient that is attached to that would be the first thing you see, right? Okay, whatever number, that's a coefficient, okay? whatever number's attached to that variable will be the first thing you see.
Loaded.
That number is called the leading coefficient. It leads in the polynomial.
Right.
And it's a coefficient. They're, once again, created. The key is make sure you're written in standard form where you go down your exponents, okay? Like if you look at the bottom, you'll see it's written in standard form because you go from the third to the second to the first to the none power. Okay?
Everything always to the first power?
Hmm?
And everything always to the first power?
I'm talking just on x's.
Oh,
See that? Just x's. Okay, so you go from x to the third to x to the second to x to the first and no x's.
Okay.
Alright? Since you go in order, the biggest exponent, which in this case would be 3, that'd be your degree. And then the coefficient that's attached to it, in this case 4, is your leading coefficient. Okay, so basically what you need to do, bless you, is if I ever ask you, what's the degree and leading coefficient, rewrite it in standard form, and then it all comes from the first term right here. Okay, degree, leading coefficient. Okay, so write each polynomial in standard form, identify degree and leading coefficient. Okay, so take the first one, we have 3x squared plus 4x to the fifth minus 7x. So you go biggest exponent first, so and the coefficients go with. So 4x to the fifth, and then going down, 3x squared minus 7x. Alright, biggest exponents to your next biggest, to your next biggest, coefficients going with them. Okay? And then it says identify the degree. I abbreviate these. Degree and leading coefficient. Okay, the degree in this case would be 5. Let me go. That looks like negative 5. There we go. And leading coefficient would be 4. Okay. That's it. All from right here. Okay, once you have it written in standard form, your degree and leading coefficient will always come from that first term. Yes, sir.
So, if it doesn't have a
Coefficient.
coefficient?
Then it's 1. No. I'll make one up like that real quick just so we cover that. Okay, so the second one there you have 5y minus 9 minus 2y to the fourth minus 6y to the third. So you rewrite it. So negative 2y to the fourth minus 6y to the third plus 5y minus 9. Be careful with your signs. Okay, the signs ahead too go with too. Okay, so like negative 2y to the fourth here, and the minus 6y becomes minus 6y cubed here. Everybody see that?
Yeah.
Okay. On this one here, your degree would be 4. Leading coefficient would be negative 2. Okay, I'm going to make one up real quick. It's going to be an easy one. X squared plus 1. What's its degree?
2.
2. What's the leading coefficient?
X.
No. 1. Okay. Coefficients. Because what's imaginary on the front of that x squared?
Oh, I'm tripping.
A 1. Okay. Just like how every time you solve for x, and you get x by itself, it's always got an imaginary coefficient of 1 there. Okay. Same deal. All right. So if you see that, your coefficient is 1. What if it was a negative x squared? Then your leading coefficient would be negative 1. Okay. So don't forget about that stuff. Now we're going to go into adding polynomials together. Find each sum. Anybody know what you do? 3 words. Combine like terms. Now, what makes something like terms? Let's refresh on this because we haven't done this in a long time now. What makes terms like? Mr. Watson. That's one of them.
Variables.
Roseman.
Variables.
I'm gonna say let's grow up just a little bit with a different word.
Letters.
Starts with a B. That's going down. That's
Oh.
going to little kids. Let's go from variables to letters. Yeah, that's cute.
Binomial.
Base.
Oh, same.
Same base, same exponent. Okay? Same bases, same exponents. Alright? So, I have an advantage because my little program here has different colors. So what I usually do for this, I go through my color, I take my color pens and everything, and I highlight my like terms. 2x squared, negative 4x squared. What you can do, and what a lot of people do, is they do like lines. Okay, so like the first set they go one line, second set they go 2 lines, and then if there's a third set, they go 3 lines. Okay, just to make sure you get them all. Okay, so it's not a full-blown requirement also, but kind of get in the habit. It'll save you a little bit of effort as we move forward into the next, probably into the next half of the chapter. It'll do you some good to get in the habit of just going and like looking for your biggest exponents first. Okay, if you ever notice that about me, I always go and like I look at my biggest exponent first. That way when I write it and I do it, I'm already in what form? If I do my biggest exponent first, I'll be in standard form, okay, from the start. So start with your biggest exponent first, so that'll be x squared. So you go 2x squared minus 4x squared to give you negative 2x squared. Remember, the bases and exponents don't change, just the numbers ahead. Okay? Okay, 5x plus 6x gives me 11x. And then negative 7 plus 3 gives you negative 4. So negative 2x squared plus 11x minus 4. Okay, so let's see. I scan my problem. Okay, I do like a Terminator scan over across of it. If I'm my biggest exponent, in this case that's 3. So I'm going to do my cubes first. So y cubed plus 2y cubed gives me 3y cubed. Alright, go through again. I find my squared terms this time, right there. Any other thing else is added to? Nope, so it's 4y squared. Alright, now I found my y's. There's 3y and negative 4y. So remember you're adding here. Okay, remember the operation. You're doing adding in the middle. See that? So you're doing 3y plus a negative 4y. So you have back-to-back signs. You have plus and negative, which essentially means you are subtracting. So 3y minus 4y gives you negative y. Okay, negative y. If you write that 1, you're cool. All right, I'm not going to tell you to get out of that habit. It's not a big deal. But to be honest, you'll never see me write that 1. Okay. And then finally your numbers, your constants there, negative 5 and 8 to give you 3. That's your answer. Okay, amazing. All right. I'm gonna go ahead and let you guys try both of these. All right. Kind of use the same. All right. Think about it. Don't rush in. Fools rush in. Okay. Don't be a fool. Okay. Think about what you are doing. Think about what operation is there in the middle. All right. There's 2 ways I could see you doing this problem. Okay. First way is this. I'm gonna put an example of both ways. Like on both problems. That's why there's 2. Look at that. Wow, I'm creative. Okay. The first way is this. You match up your like terms in your first polynomial as to your second. Okay, so you see you have 2x squared here and here, or x squared terms. You have x terms here and here. And you have constants there and there. 1, 2, and 3. Okay? And then you just kind of do it left to right, but you always remember this negative sign. Okay, so you go 2x squared minus 3x squared to give me that negative x squared, because 2 minus 3 gives me negative 1, so negative x squared. Okay. Then you go a negative 2x minus 4x to give you negative 6x, right? Negative 2 minus 4. And then you go 3 minus and negative 5, giving you back-to-back signs, which makes it a addition. So 3 plus 5 to give you 8. That's one way I see to do it. Okay. Okay. And as surprising as this may sound, that's actually not the way I do it. Okay, Anthony?
I don't know how you get the negative 2. Like, because don't you do the negative 2 plus the other 2? And those cancel out.
Negative 2 plus, you mean the exponent? Or what?
No, like when you're finding the 6x,
Mm-hmm.
you did the,
Negative 2
yeah, and then you did the,
minus 4.
yeah, but like, don't you cancel off the 2?
I don't know what second 2 you're talking about,
The
buddy.
negative 2 and x plus the 2x squared.
They aren't like terms.
Uh,
2x and 2x squared are not like terms.
alright.
This one's an x squared, this one's an x. Okay? Mr. Miller?
I did it right. I had it like in a different way. I got 8 minus 6x minus x squared.
That's fine, but like I said, I'd rather see you get in the habit of putting it in standard form as your answer. Okay, but you're not wrong. Okay. The second way I do this, and this is actually the way I do this problem whenever I'm actually just, working out problems for fun. I actually take this negative sign. I don't like parentheses. I think they make my problem look busy. So I take this negative sign in the middle, and I distribute it through my second polynomial. Okay, and then I rewrite it. 7p plus 4p cubed minus 8. And if I distribute that negative through, what's it going to do to the polynomial on the right? You both said one thing, but neither one are fully correct. Yeah, we'll say what it'll do. It will
It will multiply everything by negative 1.
multiply everything by negative 1, which does what to a number?
Change this negative or positive.
What's it called? Sign! Thank you, Mr. Watson. Sign! It changes its sign. It changes the sign of it. Okay, so we're going to distribute that negative through to make it negative 3p squared minus 2 plus 9p. Okay, so you change the sign on the polynomial that's second, okay, after the negative, and then you go through and combine like terms like you did earlier, okay, because now it looks like an addition problem, right? So you have this 4p cubed, negative 3p, or whoops, wrong, 4p cubed by itself. Then it looks like you have 1 negative 3p squared. (7p) with 9p to give you 16p positive. And then negative 8 minus 2 to give you negative 10. Okay. So it's completely up to you. To be honest, I'd rather see, for future reasons, I'd rather see you distribute that negative through and do it the second way as compared to the first. Okay, just to kind of help you get used to doing that. But you're not wrong if you do it the first way either. Word problem. The equations, I'll read it today. The equations P equals 7m plus 137 and C equals 4m plus 78 represent the number of cell phones, P, and digital cameras, C, sold in M months at an electronics store. So it gives you two equations. They use them as models. P is our phones, C is cameras, M is months. Defines your variables. Everybody good? Mm-hmm or mm-mm? Mm-hmm, mm-hmm. Let's see, where are we at? Write an equation for the total monthly sales T of phones and cameras. Then predict the number of phones and cameras sold in 10 months. So what does this problem want you to do? I want you to do two things. Mr. Miller.
Write an equation for the total monthly sales
Of?
phones and cameras.
Okay, now how are we going to go about doing that?
P equals number of cell phones and
Mhm.
cameras is C.
Mm-hmm.
So those are the two equations. The P equals 7M plus 137 and you add.
You're adding them together. Okay, because we want an equation that's going to be your total monthly sales for these two objects, right? Okay, you want one equation that's going to do your two sales. Okay, your phones and your cameras. Okay, so we're going to take the two equations, 7M plus 137, 4M plus 78. We're going to add these together, and then what does the problem tell us that it wants us to call this equation? T. Yeah, it just wants us to call it T. So T equals 7M plus 137 plus 4M plus 78. Do some like terms. Okay, so T equals 7 plus 4 gives you 11M. 137 plus 78. What is that, 215? Might be off, hold on. Right?
And then you plug.
Hold on, slow down, crazy. Predict the number of phones and cameras sold in 10 months.
You put 10 there where M is.
Why M?
Because M is
Because M represents months. Okay, so you're going to put in 10 for M. So T equals 11 times 10 plus 215. 11 times 10 is 110. Plus 215 to give you what, 325? 325 phones and cameras. Option number 2, your homework tonight is page 468 through 469. 20 through 58 even, skipping 46 through 50. Okay, so there's a few problems in there you got to get over. This is not due until Thursday with your homework quiz being tomorrow. Okay?